Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's topic, I would request you all to please subscribe my channel. So, my dear students, today's topic for the lecture is the empirical and the molecular formulas with their numericals. In this lecture, I'm going to make you understand what is exactly the empirical and the molecular formula and the relationship between the empirical and the molecular formula. So, my dear students, I'm starting with the molecular formula first. So, I'm writing molecular formula. Molecular formula. So, my dear students, what is molecular formula? It is the formula which represents actual number of atoms of all elements present in one molecule of that compound. So, I'm writing it for you. First of all, it is the formula. It is the formula which represents actual number of atoms which represents actual number of atoms of all the elements of all the elements present in one molecule of that compound. Let me take an example for you. I'm taking the example of glucose. What's the molecular formula of glucose? It's C6H12 and the O6. What the molecular formula is representing over here? This molecular formula represents that a molecule of glucose has 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. So molecular formula is representing the actual number of atoms of carbon, hydrogen and oxygen present in one molecule of that compound, that is glucose. Let me calculate the molecular formula mass. I am writing molecular formula mass of glucose. It comes out to be, what's the atomic mass of carbon? It's 12. How many carbon we are having? 6. What's the atomic mass of hydrogen? It's 1. How many hydrogens we are having? 12. What's the atomic mass of oxygen? It's 16. How many oxygen we are having? 6. It comes out to be 180. It comes out to be 180. So that's all about molecular formula. So I'm repeating it again. It is a formula which represents the actual number of atoms of all elements present in one molecule of that compound. Now let's talk about empirical formula. I'm writing empirical formula. What is empirical formula? It is the formula which represents the simplest whole number ratio of number of atoms of different elements present in one molecule of that compound. Let me write it for you. It is the formula which represents it is the formula which represents the simplest whole number ratio. The simplest whole number ratio of number of atoms of different elements, of number of atoms of different elements present in one molecule of that compound. Present in one molecule of that compound. Of that compound. Now I'm taking the example of again glucose. Example, the glucose. What's the molecular formula of glucose first? Molecular formula of glucose. It is C6H12O6. So here let me take the ratio of number of atoms of carbon, number of atoms of hydrogen and the number of atoms of oxygen in one molecule of glucose. I'm taking it to be 6 ratio 12 ratio 6, because carbon was 6 in number, hydrogen was 12 and the oxygen was again 6. The simplest whole number ratio comes out to be 1 is to 2 is to 1. Now I will use this simplest whole number ratio to show another formula, that is it's a carbon, hydrogen, oxygen. The simplest whole number ratio is 1 for carbon, 2 for hydrogen and again 1 for oxygen. So C1H2O1, this C1H2O1 comes out to be the empirical formula. Empirical formula, as this empirical formula is representing the simplest whole number ratio of different atoms, that is carbon, hydrogen, oxygen in one molecule of glucose. So it's an empirical formula for glucose. Now let us again calculate the empirical formula mass, just like we have calculated the molecular formula mass. I am writing empirical formula mass, and comes out to be how many atoms of carbon are there? 1, and its mass is 12. How many atoms of hydrogen are there? It's 1. Sorry, how many atoms of hydrogen are there? It's 2, and the mass of one hydrogen atom is 1, and that of oxygen are 6, and that of oxygen are 1, and this mass is 16, and it comes out to be 30. The empirical formula mass comes out to be 30. So my dear students, hopefully you got the molecular formula and the empirical formula. Empirical formula is just a very simple thing. It is just representing the simplest whole number ratio of different elements present in the one molecule of that compound. So now let us discuss the relationship between the empirical formula and the molecular formula. Here I am writing relationship between empirical and molecular formula. So what I'm writing over here, first of all, molecular formula mass will be equal to the n into empirical formula mass. What is n over here? N will be any whole number. So let us calculate it. What's the molecular formula mass of glucose? You can see that it's 180. I'm putting 180 for glucose, and I don't know. And what's the empirical formula mass for glucose? Just say it over here. Here it's 30. I'm putting 30 over here. My n comes out to be 6. The value of n comes out to be 6. Now where I'm going to use this value of n? Now I'm going to take it like molecular formula. Now it's just in molecular formula, not the molecular formula mass. It is just directly molecular formula will be equal to the n into empirical formula. N into empirical formula. Now, what's my empirical formula for glucose? It comes out to be, it has come out to be, dear students, please have a look. It came out to be C1H2O1. I'm using it over here. It's C1H2 and the O1. What's the value of n over here? It's 6. Now what I will do? First of all, I'm going to multiply this 6 with number of atoms of carbon. I got my carbon to be 6 ones are 6. It comes out as 6. Now what next I'm going to do? Now I'm going to multiply this 6 with number of atoms of hydrogen. It's 6 to the 12. My hydrogen comes out to be 12. It's 6 to the 12 because. Now let's talk about the oxygen. Now I'm going to multiply this 6 with number of atoms of oxygen. It comes out to be 6 ones are 6. My oxygen comes out to be 6. So I got my C6H12O6. Hopefully, my dear students, you got this thing. Now, what next? I'm mentioning one relation over here which I have taught in the previous videos, that is vapor density. Now I'm talking about vapor density. Now what was that relation? We have already understood in the previous video. So it's in the application of the Avogadro hypothesis. Exactly, the video of application of the Avogadro hypothesis have this relation, and it is actually 2 into vapor density will be always equal to the molecular mass. I have told this thing because it will be very helpful while solving the numericals. That's why I have already told about the vapor density. So my dear students, hopefully you got the empirical and the molecular formula. Now let's solve some of its numericals. So that's my first numerical. Now what it is saying, or what is it asking? A compound contains sodium, sulfur, hydrogen and oxygen. Sodium, sulfur, hydrogen and oxygen, and gave the following result on analysis. That's in percentage. Is sodium 14.28%. Okay, now further he is asking, calculate the molecular formula of the compound if all the atoms of hydrogen in the compound are present in the combination with oxygen as water of crystallization, and the molecular mass is given. So my dear students, This we will talk about later. Firstly, we will calculate the empirical formula. Now I'm going to give you the set of rules that you have to use during calculating the empirical formula. Please, it's a set of rules that you have to understand very carefully. Now, first of all, I'm writing, assume the total mass of solution to be 100 grams. Here I'm writing, assume the total mass of compound to be 100 grams. So the sodium is 14.28%. We can take it like 14.28 grams. My sulfur is 9.92%. You can take it like 9.92 grams. My hydrogen is 6.2%, or you can take it like 6.2 grams. And finally my oxygen, it is 69.6%. It comes out to be 69.6 grams. Now I'm going to give you that set of rules. You have to solve this type of question in a tabular way. Now first of all, I'm mentioning my all the elements. These are sodium, sulfur, hydrogen and oxygen. Now they're given weights. I'm writing given weights because it is represented by W. I have taken it to be W. What's the weight of W given in question? It's 14.28 grams. Sulfur 9.92 grams. Hydrogen, it's 6.2 grams, and oxygen, it's 69.6 grams. Now let us calculate about their atomic weights. What's the atomic weight of sodium? Is 23. Sulfur is 32. Hydrogen is 1, and that of oxygen is 16. Now let's calculate the number of moles. Number of moles are represented by small m, and the formula for number of moles is given weight by molecular weight or atomic weight. We have already done this thing in the previous lectures. The number of moles of any compound is equal to the given weight by molecular weight. So it comes out to be firstly 14.28 divided by 23, and it comes out to be 0.62. Now 9.92 divided by 32, that's for sulfur, it comes out to be 0.31. For hydrogen, 6.2 divided by 1, it comes out to be 6.2, and that of 69.6 divided by 16, and it comes out to be 4.35. Now let us calculate the simple whole number ratio. I'm writing simple whole number ratio. How you have to evaluate the simple whole number ratio? You have to just first of all check out your all values of number of moles, that is this thing. In all this value, just mark the value which is the lowest one, and it is 0.31. Now divide all the values of number of moles by the lowest value, that is 0.31. That means what I'm going to do, I'm going to divide all the values of moles by the lowest value of mole, which came out to be 0.31, and it comes out to be 2. Now 0.31 divided by 0.31, it comes out to be 1. Now 6.2 divided by 0.31, and it comes out to be 20. And lastly 4.35 divided by 0.31, and it comes out to be 14. So I got this thing. So the simplest whole number ratio, it will represent the empirical formula. So let's write the empirical formula. My empirical formula comes out to be empirical formula. Firstly, we are having 4 elements, that is sodium, sulfur, hydrogen and oxygen. What's the value of sodium we got in the simplest whole number ratio? It comes out to be 2. So I'm writing 2 over here. For sulfur I got it to be 1. So I'm writing 1 over here. For hydrogen I got the value of 20. So I'm writing 20 over here. And for oxygen I got 14. So I'm writing 14 over here. So that is my empirical formula. Hopefully, my dear students, you got the way how I have calculated the empirical formula. Now let us calculate the empirical formula mass. I'm writing empirical formula mass. How you have to evaluate it? Now, what's the atomic mass of sodium? It's 23. How many sodium are there? 2. What's the atomic mass of sulfur? It's 32. How many sulfur are there? It's 1. What's the atomic mass of hydrogen? It's 1. How many hydrogens are there? 20. What's the atomic mass of oxygen? It's 16. How many oxygens are there? 14. When I calculate it, I got my value to be 322. So I got my empirical formula and empirical formula mass. Now let's come back to the question. In question, the molecular mass of crystalline salt is given to be 322. So I'm coming back to the question, solution. I'm writing molecular formula mass. Molecular formula mass, and again in question it's given to be 322. So I'm evaluating n over here. My n will be equal to the molecular formula mass divided by empirical formula mass, and it comes out to be 322 divided by 322. It comes out to be 1. It means that the empirical formula is my molecular formula in this case, and it comes out to be Na2S1H20 and the O14. So I got my empirical formula. Now let's come back to question. Now what question is saying? Is saying that all the atoms of hydrogen in the compound are present in the combination with oxygen as water of crystallization. This means that water of crystallization stands for H2O, and he is saying all the hydrogen of the molecular formula are present in water of crystallization. Now let's come back over here. That means here we are having 20 hydrogens, and what is water of crystallization? It is actually H2O. He is saying that all the 20 hydrogens are present in H2O. That means I have to multiply my H2O with 10. So it comes out to be 10 to the 20. My 20 hydrogen are completed. Now, how many oxygen are there in water? It comes out to be 10 oxygens. That means we are having total of 14 oxygen. I have to subtract 10 from it. It comes out to be 4. That means my oxygen are left to be 4. My sulfur is now 1 and Na is 2. So that is my exact molecular formula, that is Na2SO4 dot 10H2O. Hopefully my dear students, you got this question. In the question it is mentioned that all the hydrogen of molecular formula are present in water of crystallization, that is H2O. That's why I have multiplied my H2O with 10, because there are 2 hydrogen in one H2O. So it comes out to be 10 2s are 20 and 10 oxygens are there. Total oxygens were 14. I have subtracted 10 oxygens from there. I left with 4 oxygen. So I have taken over here. It comes out to be Na2SO4 dot 10H2O. So hopefully my dear students, I have completed my first numerical. Let's move to the another numerical. Now, what this numerical is saying: a compound contain 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. Its molecular mass is 98.96 grams. What are its empirical and the molecular formula? So again, I'm writing: assume the total weight of compound to be 100 grams. So my hydrogen, which is 4.07%, it becomes 4.07 grams. My carbon, which is 24.27%, becomes 24.27 grams, and chlorine, which is 71.65%, is taken to be 71.65 grams. So now let's come back to again our tabular form, and please focus on the set of rules. So I'm writing carbon, hydrogen, and chlorine. What are their given weights according to question? Carbon is 24.27 grams. What's hydrogen? It's 4.07 grams, and chlorine, it comes out to be 71.65 grams. Now what are their atomic weights? The carbon is 12, the hydrogen is 1, and chlorine is 35.5. Now evaluate the number of moles, which are calculated like given weight divided by atomic weight or the molecular mass. So it comes out to be 24.27 divided by 12. It comes out to be 2.02. Now 4.07 divided by 1, it comes out to be 4.07, and 71.65 divided by 35.5, it again comes out to be 2.02. Now let's talk about the simple whole number ratio. I'm writing simple whole number ratio again, have a look of all the number of moles. Have a look of all the number of moles and mark the lowest value. In all these three values, I got it to be 2.02. Now divide all the values of number of moles by 2.02, that is the lowest value. I'm coming back to question. I'm writing firstly 2.02 divided by 2.02, it comes out to be 1. 4.07 divided by 2.02, it comes out to be 2. And 2.02 divided by again 2.02, it comes out to be 1. What I have done over here, I have divided all the values of number of moles by the lowest value of number of mole. Hopefully you got it. So I have divided all the values of moles by the lowest value of the mole, which is 2.02. So my empirical formula comes out to be, I'm writing my empirical formula comes out to be, I'm writing carbon, hydrogen and chlorine. Here, what's the value of carbon? It's 1, so I'm writing 1 over here. For hydrogen it's 2, so I'm writing 2 over here. And for chlorine it's again 1, so I'm writing 1 over here. So that's my empirical formula, C1H2Cl1. So again, by rule, let's calculate the empirical formula mass. I'm writing empirical formula mass. What's the atomic weight of carbon? It's 12. How many carbons are there? 1. What's the atomic weight of hydrogen? It's 1. How many hydrogens are there? 2. What's the atomic mass of chlorine? It's 35.5. My answer comes out to be 49.5. So I got my empirical formula and the empirical formula mass. Now let's get back to question. What here he's saying, its molecular formula mass is 98.96 gram. So this is given in the question. It is given in the question. I am saying here molecular formula mass is given in question, that is 98.96 grams. So let us calculate N. My N comes out to be molecular formula mass divided by empirical formula mass. It comes out to be 98.96 divided by 49.5, and this value comes out to be 2. So what next I am going to do? I am writing molecular formula will be equal to the N into empirical formula. So what is my empirical formula? It is C1H2Cl1. It is C1H2Cl1. What's the value of N? I got it to be 2. It's 2. So how will I calculate my molecular formula? I am writing again C, H and Cl. Now it's 2 ones are 2, so C is 2. Now 2 and D, 2 of hydrogen, it comes out to 2 2s are 4, means hydrogen are 4. Now 2 and D 1, 2 ones are 2 for chlorine, and it comes out to be 2. So my molecular formula comes out to be C2H4Cl2. I got my molecular formula and I also got my empirical formula. So my dear students, hopefully you got this numerical also. Please do have a look. Now I'm moving to the third numerical. Now in the third numerical, what is saying, an organic substance contains carbon, hydrogen and oxygen, and a percentage composition is given. The same way I would like to say, right, assume total weight of the compound to be 100 grams. So that means my carbon, which is 40.68%, I will take it to be 40.68 grams. My hydrogen, which is 5.085%, I will take it to be 5.085 grams. And oxygen, which is given to be 54.228%, it comes out to be 54.228 grams. So again I am going through my set of rules. The vapor density of the compound is 59, it is given, and I have to calculate the molecular formula. For calculating molecular formula, again I need to calculate empirical formula first. So let us find the empirical formula according to the set of rules that I have given. So I am writing carbon, hydrogen, oxygen. Let's talk about their given weights. It's 40.68 grams, 5.085 grams, and 54.228 grams. What are their atomic weights? Atomic weights. The carbon is 12 grams, the hydrogen is 1 gram, and oxygen is 16 grams. Let's calculate this number of moles, that is given weight divided by atomic weight. It will be then 40.68 divided by 12, and it comes out to be 3.39. Now 5.085 divided by 1, it comes out to be 5.085. And oxygen, it is 54.228 divided by 16, and it comes out to be 3.39 again. Now I'm going to calculate simple whole number ratios of every element with respect to each other. So the same way, see all the values of number of moles and just find the lowest value, and it is 3.39 over here. That means now I have to divide all the values of number of moles for carbon, hydrogen and oxygen by 3.39. That is 3.39 divided by 3.39, it comes out to be 1. 5.085 divided by 3.39, it comes out to be 1.5, and 3.39 divided by 3.39, and it comes out to be 1. My dear students, this ratio, the 1 for carbon, 1.5 for hydrogen and 1 for oxygen, and it is still not the simple whole number because it's in 1.5 in between. So to make it more simple, I have to multiply my all values by 2 to make it the simple whole number ratio. It comes out to be now 3, now it comes out to be 2, and now it comes out to be 2. So I got my empirical formula. I'm writing my empirical formula. My empirical formula will be CHO. So I got the value of 2 for the carbon. I'm writing 2 over here. I got the value of 3 for the hydrogen. I'm writing 3 over here. And I got the value of 2 for the again oxygen. I'm writing 2 over here. So that's my empirical formula, that's C2H3O2. So let's calculate empirical formula mass first. I'm writing empirical formula mass. Now, what's the atomic mass of carbon? It's 12. How many carbons are there? 2. Plus, what's the atomic mass of hydrogen? It's 1. How many hydrogens are there? It's 3. What's the atomic mass of oxygen? It's 16. How many oxygen are there? It's 2. And it comes out to be 59. So I got the first of all empirical formula and empirical formula mass. That's an empirical formula and empirical formula mass. Now let's get back to question. Here what it's saying. The vapor density of the compound is 59. Calculate the molecular formula. Now let's use this vapor density. Vapor density. Vapor density is 59. What's the formula for vapor density? It's molecular mass divided by 2 is equal to vapor density, and it comes out to be 59. My molecular mass comes out to be 2 into 59, and it comes out to be 118. I got my molecular mass. So now again let's calculate n. My small n comes out to be molecular formula mass divided by empirical formula mass. What's my molecular formula mass? I got it to be 118. And what was my empirical formula mass? I got it to be 59, and it comes out to be 2. Now, my molecular formula will be equal to molecular formula will be equal to the n into empirical formula. Now let's back over here. What was my empirical formula? The C2H3O2 was my empirical formula. It is C2H3O2. I'm writing C2H3O2 into. Now, what's the value of n? I got it to be 2. So I'm writing 2 over here. So let's talk about our molecular formula. I'm writing 3 elements: carbon, hydrogen, oxygen. So for carbon, first of all, it's 2 to the 4. So carbon are 4. For hydrogen is 2 3 is a 6. For hydrogen it comes out to be 6. For oxygen it comes out to be 2 2 is a 4. So oxygen comes out to be 4. So that is my molecular formula. It's C4H6O4. Hopefully my dear students, you got this numerical also. So I'm moving to the next numerical. That's the numerical number 4. A crystalline salt when heated becomes anhydrous and loses its 51.2% of weight. The anhydrous salt on analysis gave the percentage composition of this magnesium sulfur oxygen. Calculate the molecular formula of anhydrous salt and crystalline salt. Its molecular mass, if the molecular mass of anhydrous salt is 120 grams. So first of all, my dear students, crystalline salts stand for which are having water of crystallization. The first numerical that we did today. I'm coming back to the first numerical. In the first numerical, my answer came out to be Na2SO4 dot 10H2O. I got 10H2O. This H2O is called water of crystallization. When these water of crystallization in any number are linked to any salt, then that salt is called crystalline. That means this salt is crystalline salt. Now, if we heat this salt, if I am heating this salt, I am writing heating, then what will happen? Na2SO4 will lose all its water of crystallization. Now Na2SO4 is alone, that is without water of crystallization. Then this is called anhydrous salt. So hopefully, my dear students, you got a difference between the crystalline salt and the anhydrous salt. Now let's come back to the fourth numerical. Let us first of all talk about the empirical formula. So here again I'm saying let the weight of anhydrous salt to be 100 grams. So my magnesium will become 20 grams, 20% to 20 grams. My sulfur will become 26.66 grams, and my oxygen will become 53.33 grams. Now I'm going through my set of rules. I'm writing magnesium, sulfur, oxygen. Their weights 20 grams, 26.66 grams, and 53.33 grams. Their atomic weights. For magnesium, it comes out to be 24 grams. For sulfur, it's 32 grams. And for oxygen, it's 16 grams. Now the number of moles. The number of moles is given weight divided by atomic weight over here. So it comes out to be 20 divided by 24, and it comes out to be 0.83. Now for sulfur, 26.66 divided by 32, it again comes out to be 0.83, and for oxygen, 53.33 divided by 16, and it comes out to be 3.33. Now let's talk about the simple whole number ratio. Simple whole number ratio. Again, my dear students, go through the all values of number of moles and find the lowest one. This is the all values of number of moles. The lowest one is obviously 0.83. So what I'm going to do, I'm going to divide all the values of number of moles, that is of magnesium, sulfur and oxygen, by the lowest value, that is 0.83. So it comes out to be 0.83 divided by 0.83, that is 1. Now 0.83 divided by 0.83, it's again 1. And now 3.33 divided by 0.83, it comes out to be 4. So my empirical formula, I am writing my empirical formula, it comes out to be magnesium, sulfur, oxygen. Now what's the value for magnesium is 1, that's magnesium stands for 1. Sulfur is 1, now sulfur is 1. 4 for oxygen, so I'm writing 4 for oxygen. So it's Mg1S1 and the O4. That's my empirical formula. So now let's calculate the empirical formula mass. Empirical formula mass. Now what's the atomic mass of magnesium is 24. The atomic mass of sulfur is 32. And the atomic mass of oxygen is 16. Oxygen are 4 in number, 16 4s are 64. Now this addition comes out to be 120 grams. So now let's come back to question. In the question, what is given? If molecular mass of anhydrous salt is 120 grams. So I got the molecular mass of 120 gram in the question. So I'm coming back to my over here. I'm writing molecular mass given in question. It's 120 grams. So what's the value of N? It's molecular formula mass divided by empirical formula mass. It comes out to be 120 divided by 120 because molecular mass was 120 and we got the empirical mass to be 120. So it comes out to be 1. This signifies my empirical formula and the molecular formula is the same thing over here. So my molecular formula is same as that of empirical formula. It is MgSO4. I got magnesium sulfate. Now this is the formula for anhydrous salt, that is without water of crystallization. We have to find the molecular formula of crystalline salt. Now let's come back to question. He is saying a crystalline salt when heated becomes anhydrous. Obviously it will lose all its water of crystallization and loses its 51.2% of weight. That means I'm coming back over here. Let my crystalline salt to be magnesium sulfate dot XH2O. When we will heat it, it will become magnesium sulfate plus XH2O. Now the question is saying when we heat magnesium sulfate, it loses its 51.2% of weight. That means magnesium sulfate is magnesium sulfate dot XH2O after heating losing its 51.2% of weight. When we heat the magnesium sulfate dot XH2O, the magnesium sulfate dot XH2O loses its 51.2% of weight. That means the water over here is 51.2% of crystalline magnesium sulfate. So what is left? So what is the percentage of magnesium sulfate then? It is 100 minus 51.2, and it comes out to be 48.8%. So this is the thing that I have evaluated. In the question it was given that magnesium sulfate .xH2O on heating loses its 51.2% of weight. Now we know that when we heat any crystalline salt, it loses its all water of crystallization. It loses its all water of crystallization, and they were actually 51.2% of total weight of crystalline salt of magnesium sulfate. Now what's remaining? That means magnesium sulfate MgSO4 is 48.8% of total weight, but I have just calculated the magnesium sulfate weight, and it is 120 grams. So that means let no that means 120 gram is 48.8% of total mass of MgSO4 dot XH2O. Hopefully my students, you got this point. I got the percentage of magnesium sulfate to be 48.8% of total weight, but I know the weight of magnesium sulfate is 120, which I have just calculated, and even molecular mass of 120 gram was also given in the question. So that means 120 gram is 48.8% of total mass of magnesium sulfate dot XH2O. So let's calculate it then. That is 120 is equal to the 48.8% of total mass of MgSO4 dot XH2O. So I'm writing total mass of MgSO4 dot XH2O. It comes out to be 120 into 100 divided by 48.8, and this value comes out to be 246 grams. So I'm again writing the reaction. I'm writing magnesium sulfate dot XH2O on heating gives MgSO4 plus XH2O. Now I got the total mass of magnesium sulfate dot XH2O to be 246 gram. That means this is 246 grams. What's the weight of magnesium sulfate? I got it to be 120 grams. So what's the weight of this total XH2O? So it will be obviously 246 minus 120, and it comes out to be 126 grams. So that means mass of XH2O will be 126 grams. So my motive here is to find the value of this X. So let's find the value of this X now. The mass of one H2O. What's the atomic mass of hydrogen? Is 1. How many hydrogen are there? 2. Atomic mass of oxygen is 16, and it comes out to be 18 grams. That means X into 18 will be equal to 126. So my X comes out to be 126 divided by 18, and it comes out to be 7. That means the value of X is 7. That means I am having That means, my dear students, I am having water of crystallization to be 7 in number. And what was my salt? It was magnesium sulfate. So I got the formula of crystalline salt, that is magnesium sulfate dot 7H2O. That was my motive. Hopefully, my dear students, you got the last numerical. It was a bit confusing and tough one, but if you study it very carefully, or you um listen to my this lecture very carefully, you will surely get this numerical. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear doubts, he can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.